Even the. Can you write on the board and let's see? Thank you. Happy Mother's Day to potential mothers. It's not bad. Can you open the lines a little and let's see? A little. Are you afraid? Okay, you write and let me see. Listen, it's not bad. Yeah, I think it's better with the lines. Okay, I'll be back.
Have you got live for it? Okay, yeah, sure.
Let me share. I just share it.
Okay. Hello and welcome to today's lesson on the Femafric channel, the PAMAT series that we've been having for some time now. Today we're taking the topic probability, and we are going to look at some basic concepts in probabilities and then move on to solve some past questions on the BEC under probabilities. So today is Mother's Day, so happy Mother's Day to all the mothers who are watching and then giving their children the chance to participate in this lesson. But this is my question. Today being a Mother's Day, let's assume that there is a mother with two daughters. I say Michelle and Jemima. Michelle is working at the airport. She takes a lot of money. And then Jemima is maybe a shop owner who has just a few things to sell to get money. Now the question is, on this Mother's Day, who is likely to send the mother a gift? On this Mother's Day, what is the probability that one of these children is going to bring a gift home? So this idea about probability is just about it. So now we are looking at who is bringing something home. And then you can measure this by where the person is working or the kind of love that the person has for the mother. So if we are taking it on the basis of where the person works, it is possible that the one who is working at the airport who has a lot of money is likely to bring home something, because the money she is getting, taking just a small piece of it and buying something for the mother won't be anything a big deal to handle. But the one who is running a small shop will be thinking about the little profits that she's been getting and then how taking the money will be. So maybe she'll just pass by the home and then say hi to the mom and go about her own way. So that is basically what probability is about. So we are saying that probability is just like the fractions we have been doing all along. only that here our fraction is restricted between 0 and 1. 0 and 1. So anytime you work any probability question and you are getting a negative or you are getting anything beyond 1, you should know that there is something happening which is not right. How do we calculate probability? We are saying that anytime you want to calculate probability, two things should come to mind. The first thing should be the event. When we talk about the event, we are looking at what we are interested in. What we are interested in. So let's say that I have a coin, and then on a coin we have a head and a tail. So if I toss a coin now, there are two things that can happen. Either a head will show up or a tail will show up. The likelihood or me saying that I am interested in head means that I am finding that event, or me saying I want a tail is another event. So we look at the event, that is what we are interested in. The second thing that we should be looking at is what we call the sample space. So the sample space here too refers to all the possible things available to you that you want to choose from. All the possible things available to you that you want to choose from. So in the case of still the coin, I have two possibilities, a head and a tail, meaning that those two things are what I am always going to choose from. I can say I just want a head or I just want a tail. But in both cases, I have to take from those two, which is head and tail. Okay, so now knowing this event and then the sample space, we define probability as being equal to the event divided by the sample space. And in both cases, we are just going to look at the number involved in here. So you look at the number involved in this event that we are looking for, and then we divide it by the total number of things in our sample space. So that is what we are going to do. Most times, people get confused, especially when the sample space are things that deals with numbers. So they get a little confused as to what exactly should be done. And that is the duty for today. I'm just going to take you through some past questions, and then we see how questions like that can be handled. So let's take the very simple example of the head and the tail. So we know that for a coin, like I've mentioned, we have two sides of it. We have the head and then the tail. So it means that if I take a coin, if I want head, head only appears one on a coin. And then the tail also appears one on the tail on the coin. So it means that when I take a coin, there are two sides of it. So if I want to find the probability of a head showing after I have tossed a coin once, then I am saying that that is going to give me one out of the two possibilities. Here, the event of having a head is what I am looking at. And then on the coin, there is only one chance of it happening out of the two possibilities on the coin. If I am taking the probability of a tail showing up, that is also going to give me one out of two in there. So the basic idea here is that in a probability question, we are saying that assuming I have this container, and inside this container, I have a number of identical things. We are looking at identical because we don't want to give some of the things upper hand over the others. So it is identical in shape and everything, maybe just not in color. So let's say I have these things here. Okay, so here I have 7 circles placed in, let's say, a container. However, we have some of them which are shaded, the other which is not shaded. So here the events we can think about is one, a shaded circle, and then the other one is non-shaded circle. So these two things are my events. The shaded circle because I can see them here, and then the non-shaded can also be found here. But when I put all of them together in that container, we call that container my sample space. Because out of that space is where I'm going to derive the things that I want. So the question is, if I want to say that I want to pick just one circle out of this container, then what is the likelihood? What is the chance? What is the possibility? All these words are words that we use to describe probability. That what I'll bring out of this thing at random is going to be a shaded one. Naturally, you should know that because the shaded ones are less than the unshaded one, the likelihood or the possibility that I am going to bring out a shaded one will be a little lower, a little lower as compared to the other one. Because if I have 4 things and 3 other things all in a bag, to get something out of it, you are likely to have the one which is more coming out. It doesn't mean that the smaller ones cannot come up. It can come out, but out of how many chances? That is what you are looking at. So here we see that the shaded one, there are 3 in the box, and then the non-shaded ones are 4. Now in my sample space, I have 7 different circles in there. In the shaded, in the sample space, 7. So now if I want to find the probability of bringing up a shaded circle, then this should be equal to the event or the number of shaded circles, the number of shaded circles in here. So that should give me 3, and then I divide it by the total number of circles in here. That should be 7. Then when I go to the probability of the non-shaded, that should also be the number of non-shaded circles in this box or container, which is 1, 2, 3, and 4. So I have my 4 here, and then I divide it by the total number of all the circles in that same container, which is also 7. Now let's watch something. Let's say we want to add 3 out of 7 to 4 out of 7. Now from fractions we studied last week, it tells us to find the LCM, and here the LCM is 7. So 7 into 7 is 1 by 3, should give us 3, and then plus here will be 4. So this gives us 7 out of 7, and that gives us 1. So it means that if you have a certain container and we look out for all the possibilities, all the probabilities in there, the sum of all the probabilities in that sample space should sum up to 1. If you are going to consider everything in that sample space, then you are going to get a summation of 1. In probability, we say that if you get any fraction which is not 0 or which is not equal to 1, then we call it a probability. However, if you calculate a probability and you get the answer being equal to 0, Technically, we call it uncertainty. Uncertainty. No, we call it impossibility, sorry. Call it impossibility. And then when you get one, we call it certainty. And then everything in between is the uncertainty. That's where we have the probabilities coming out. So let's assume that from this sample space I have here, I say that give me the probability of getting a half circle. A half circle. Inside this sample space, it's either a shaded circle or a non-shaded circle. So if I ask you to find a half circle, there is no way you can get a half circle from this sample space that I've given to you. So it means that the number of half circles here is going to be equal to 0. And then the sample space is 7. And this results in 0. So it is impossible. You cannot get a half circle out of the sample space that I have given you. Okay. Now let's take our examples from the BC and then see what are some of the questions that may come. Okay, so my first one. Okay, so the question reads, a boy throws a fair die once. What is the probability of getting the number 1? What is the probability of getting the number 1? When you are given a question like this, the first thing that you should think about is when you take a fair die, what are the things that are on it? What are the numbers that can show up when you throw a dice? So when you take a die, you all know that there are 6 numbers in there. So it's either 1 may show up, or 2, or 3, 4, 5, or 6. In each of these, the number 1 only appears once on the die. Same for 2, for 3, 4, 5, and then 6. So this is the number and then this is the frequency, the number of times it appears on the fair die. Okay. So now the question says that we should find the probability of the number 1 showing up. So what you do is that you look at this table and then you know there is 1 here. So we are looking at the number 1. So you go to the number side and then you look out for 1. Now we are looking for the probability of the number 1. And we are saying this should be equal to the number of ones that you can see on a dice. So when I take a dice, I can only see one just one time. One time. So that should be equal to 1 here divided by how many numbers are on the dice. How many numbers are on the dice? There's 1, 2, 3, 4, 5, and 6. And each of them appears just once. So when I sum this, 1 plus 1 is 2, plus 1, 3, 1, 4, plus 1, 5, plus 1 is 6. So the probability of having the number 1 is equal to 1 over 6. This question brings a confusion to most students in that if they are asked to find the probability of, say, getting the number 4, they tend to believe that because the probability of getting a 1 is 1 over 6, it means that the probability of getting the number 4 will also be equal to 4 over 6, and this is wrong. This is wrong. The probability of getting the number 4 still tells you that go back to this table that you have created for yourself. Look out for the number 4. So this is the number 4. But when you had the number 4, how many times did it appear? How many times did it appear on your dice? How many times did it appear on your dice? And we know that it appeared just once. It appeared just once, so this should be 1 over how many numbers are there on the dice, and that is 6, and that should also be this. So it means that when you take a fair dice, you don't say that because the probability of the number 1 coming up was 1 over 6, if I want the probability of 2, it should be 2 over 6, 3 should be 3 over 6. No. You rather look at how many times that particular number you are interested in is appearing on your dice. So if I take 6, the number 6 only appears 1 on the dice, just one time on the dice. So that will be 1 over 6. So in effect, all these numbers are going to appear with a probability of 1 over 6. So that when I sum all of them together, I get the total probability, which is 1. Okay. Let's take another question. Question 2 says that there are 12 red and 8 blue balls in a bag. If a ball is selected at random, from the bag, what is the probability that it is red? Okay. So this problem is just like the one that we did for this side. So there are 12 red and 8 blue balls in a bag. So here, what you consider is to imagine that there is a certain bag and there is something like this in there. And then inside that bag, 12 of the balls in there are red, and then the other 8 are blue. And we want to find the probability of selecting a red. So your probability of getting red should be equal to the number of red balls in the bag divided by the total number of balls. Okay, so here the question has made us aware that the number of red balls are 12, so you just substitute the 12 here and you divide by the total number of balls. The total number of balls are going to be just the 12 red balls plus the 8 blue balls, and that should give you 20. So here you divide by 20. Then your probability is simply 12 over 20. But you know that in fractions, 12 over 20 can be simplified further. So you go ahead and you simplify that by dividing through by 4. So that 4 goes here 3 times and can divide 20 5 times. So the probability of you getting a red ball is simply going to give you 3 over 5, which should translate to 0.6 in decimals. 0.6 in decimals. Okay. Another question. The letters in the word hippopotamus are placed in a box. What is the probability of taking out a letter that is a vowel? Okay. So the letters in the word hippopotamus are placed in a box. What is the probability of taking out a letter that is a vowel? So here, you must know what a vowel is. You should know the difference between vowels and consonants, which you should know this from your English class. So, to simply give you an idea, when we talk about vowels, we are looking at letters like A, E, I, O, and U, at least in the English alphabet. These are the vowels. So from the word hippopotamus, if I am looking for the probability of selecting a vowel, then I should count total number of vowels. So this should be equal to the number of vowels, and then we divide it by the total number of letters. Total number of letters. Okay. So from here, I can count I here, and count O, A, and U. So that should be 1, 2, 3, 4, 5. So the total number of vowels here, 5, divided by the total number of letters in hippopotamus, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you have the word hippopotamus and you want to find out the probability that a letter selected from that word is going to be a vowel, then you have a probability of 5 over 12. The next question. "18 cards are numbered from 11 to 29. If a card is chosen at random, what is the probability that it contains the digit 2? Okay, so I read the question again. 18 cards are numbered from 11 to 29. If a card is chosen at random, what is the probability that it contains the digit 2? So here you have in mind that there are 18 cards that you are going to get. So we are finding the probability of containing the digit 2. So when you talk about a digit, you are looking at just a number. That's number 2. So if I have, let's say, a number like 23, 23 contains the digit 2, it is here. If I look at the number 32, that one also contains the digit 2, it's here. If I look at 102, it contains the digit 2, like that. So this is what we are looking at. So we have been given 18 cards which has been numbered from 11 to 29. So here the ideal thing to do is that you can get the number 20 itself, contain the digit 2, and all the other 20 numbers will also have. So like 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay. So all these numbers contain the digit 2. Contain the digit 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of the 18 contains the digit 2. However, don't forget that the numbering started from 11. So it means that I could go to 12. And 12 also contains the digit 2. 12 also contains the digit 2. So it means that in total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of numbers which contains the digit 2 is 11. And then the total number of cards there is 18. So the probability is going to give us 11 out of 18. So at least at your level, probability questions are very straightforward and very easy. So you just have to consider whatever has been given to you. You think through it carefully, and then you produce the answer. Just looking at the number of the events that you are interested in, and then you divide by the total number in your sample space. Next question. Okay. The next question says that the ages in years of 10 children at a party are 2, 3, 3, 3, 4, 4, 5, 5, 5, and 6. So you go to a children's party, and then the youngest there is 2 years old, the oldest there is 6 years old, and then you have a mixture of 3 years, 4 years, and 5 years, but the total number of children at the party is 10. Now, if a child is chosen at random, if you just go pick one of them out, what is the probability, what is the chance, or what is the possibility that that child, he or she, is not less than 5 years old? So here you bring in the ideas of inequalities. So it's telling you that the child is not more than, it's not less than 5 years old. So if somebody is not less than 5 years old, then it means that that person will be 5 years or above. So 5 years and above. Because they are saying you are not less than 5 years old. If you are not less than 5 years old, then it's either you are 5 years exactly or something more than 5. So here we are going to find the probability of selecting a child who is not less than, so probability of not less than 5 is going to be equal to the total number of children who are 5 years old and above. So here we have 1, 2, 3 people being 5 years, and then one more person being 6 years. So in total, the total number of children who are not less than 5, who are not less than 5 is going to give us 4 here out of the total number of children who are there, which is also 10. Once again, you are cautioned that just because they mentioned the number 5 doesn't mean that this side is going to be 5/10. No, we are counting the number of something, not looking at just the number which was mentioned in the question. In the case of the die, I told you that if they say find the probability of 4 showing up, it shouldn't be 4/6. So the same thing here. So this can also be simplified further, because we know 2 can divide 4 2 times and can divide 10 5 times. So the probability of selecting a child who is not less than 5 years old is going to give us 2 out of 5. Another question. The table below shows the frequency. Frequency means number of times. The frequency distribution of the number of letters in the surnames of some students of a school or in a school. So the first row is the number of letters in the surnames, and then the second one is the number of students. So when we take surnames that contain just 4 letters, we have 7 students having such. When we take 5 letters for a surname. We have 3 students having it. 6, we have 2 students. And we take 7, we have 8 students. We take the letter 8 letters, we have 5 students having that. And we take 9 letters forming a surname, we have 3 students. And then when we look at 10 letters forming a surname, we have just 1 student. Now the question is, so this is the frequency distribution table we are talking about. So if a student is selected at random, what is the probability that he or she his or her name will contain more than 7 letters. In the last example we were looking at not less than 5. Now in this example we are supposed to find the probability that the name contains more than 7 letters. Most times when we are faced with a problem like this, we are tempted to believe that when we talk about more than 7, it's just 8. But we can know that 8, yes, is more than 7. 9 is also more than 7. And then 10 is also more than 7. 7 is not more than itself. So we are interested in the number of students whose surname contains more than 7 letters. So the first row in our table is telling us the number of letters. And then this second one is telling us the number of students. We are selecting a student. So the probability of having name containing more than 7 letters should be equal to the number of students who have their names having more than 7 letters. So students who have 8 letters, 9 letters, or 10 letters making up their surname, they are the ones that we are interested in. So when we look at 8 letters, we have 5 students, 9 letters, we have 3 students, and when we look at 10 letters, we have a student. So in all, we have 9 students. So this will give us 9. And then we divide by the total. So the total is going to be a summation of all these. So we have 7 plus 3, 10, plus 2 is 12, plus 8 is 20, and then this is 9. So that should give us 29. Taking our last example, and it says that the following shows the distribution marks of students in an examination. Okay, so some students wrote an exam in a certain subject and these are their marks or their score. So we have 6, 43, 26, 18, 27, 42, 8, 22, 31, 39, 55, 44, 37, 47, 59, 10, 12, 36, 53, and then 48. Okay. The question is to find the probability of selecting a student who scored between 40 and 50. So you have looked at not less than, you have looked at not more than, or you have looked at more than, you have looked at not less than. Now we have been given a challenge to find between. So you are finding the probability of selecting a student who scored between 40 and 50. So here you ask yourself, what are the numbers that are between 40 and 50? What are the numbers that are between 40 and 50? So the numbers which are between 40 and 50 are 41, 42, 43, 44, 45, 46, 47, 48, and 49. So here, that is what you are going to look out for in these numbers which has been given to us. So in the first row, we can see the number 43, so we take it out. In the second row, we can see 42 here. In the third row, there is 44, there is 47. In the last row, there is 48. So then, the numbers here, which are between 40 and 50, are 1, 2, 3, 4, and 5. So, the probability of having between 40 and 50 is going to be equal to the number of numbers here which are between 40 and 50, which is the 5 we have crossed out, divided by the total number of numbers here, which is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 20. And when I simplify this down, that should give me 1 out of 4, which in decimal should give me like 0.25. So this brings us to the end of today's lessons on probability. Hopefully we'll meet next week and consider another topic. Thank you.